Okay, so page 2 is going to be factoring using a difference of squares. Okay, so this is page 2 in your brochure. Should be directly next to the greatest common factor method. And we are going to first do one review problem. So if I give you x plus 4 times x minus 4, if we were to simplify that, we would use the FOIL method, or you can use the box method. So x squared minus 4x plus 4x minus 16. And then we're going to combine like terms, which becomes a 0, so x squared minus 16. That is our simplified answer. So now what we're going to do is work backwards, because this resulting product is called the difference of squares. And as you can see, we have a perfect square of 16 and a perfect square of x. So to factor a difference of squares, use the following rule. Anytime we see a squared minus b squared, it is the same as saying a plus b times a minus b, which is as you see it up here. So now we're just defining a rule for it. Okay, so I'm going to give 2 examples that I will show, and then I'll give 2 that you need to return to class with. So a squared minus 4. We need to work backwards and figure out the difference of squares. Well, we need to work, so we're figuring out, we're going to factor the following difference of squares. So what is, if we have a, we know we have 2 a's we're working with, based on this a being squared. And we know we have one of them is a plus and one is a subtraction sign based on our rule. And now we have to figure out a number that when multiplied together gives us 4. Because it's a perfect square, we know that the square root of 4 is 2. So we can plug that number in. Okay, that is our factored difference of squares. If we were to FOIL it back, we would see that it equals a squared minus 4. Okay? C squared minus 100, we're going to factor it. We know we're working with 2 binomials. We know we're working with C as the first term, a plus sign, and a subtraction sign. The process is the same every time. Now we're looking for the perfect square of 100, square root, and that is 10. And that's our factored solution. Okay, one more actually. K squared plus 25. Because there is an addition sign, we can't factor it, nothing will work, so it is prime. This will not work for a difference of squares. We have our rule, we have to follow it. Let's look at number 12. We've decided to go a little bit further. 64 u squared minus v squared. We want to factor it. We know one of them is addition, one is subtraction. Okay, we know we have a u as our first term. And so we now have this coefficient in front, which is a 64. So we know that what's the square root of 64? Well, it's 8 and 8. So 8u times 8u gives us 64u squared. So that's done. And then we need to figure out v and v, because if we do, the thing is if we do, we FOIL, we have 64u squared, 8uv, which is negative, 8uv, which is positive, so they cancel each other out, and then we're left with negative v squared, so we know it's correct. Okay, so it's all about patterns in algebra. Okay. So this is it for these simple problems. I'm going to give you a couple to look at. So number 5, we need to look at this one. For you to bring to class, 4c squared minus 5d squared. And the second example is 64m to the 4th minus 16. Okay, and then if you want to summarize the rule in your own words, that will go at the bottom. Real quick, we might have mixed factoring. If you look at number 20, if you look at this example, 36x cubed minus 9x, we are first going to factor it. We're first going to take out using greatest common factor rules. So we know we're going to take out an x because they both have an x in common. And we know we're going to take out a 9 because they both have a 9 in common. 9x comes out. So 4x squared minus 1. Now we can take the difference of squares and factor that. So we have 9x, and then we know that we have something with addition, something with subtraction. We know we're dealing with an x and a 2, because 2x times 2x is 2x squared. And then we know we are dealing with a 1. Because 1 times negative 1 is negative 1. Okay, so in this case we've had to do greatest common factor, plus we had to do the difference of squares and factor that. Okay, so an example for this one you can bring to class is 3x to the 4th minus 48x squared. So give me your greatest common factor, take that out, and then I want you to factor the difference of squares.